Now let's try to check the collision with the walls. So if you see this Pong game, we don't have to worry about the right and left walls because when the ball hits the right or left wall, game is over. If the paddle is not able to catch the ball, game is over. But I mean, in the sense, game is over in the sense the point will go to the other side. We don't have to basically recognize that, but we have to recognize the collision with the top and bottom walls. Okay, so now what happens is when the ball is going up top, its y coordinate is increasing, and when it hits the top wall, it has to come down, and its y coordinate has to decrease. So the same thing on the bottom wall. If it is going down, y coordinate is decreasing, and once it hits the wall, it has to y coordinate has to increase. So only thing that you have to work on while detecting the collision with the wall is the y coordinate. How do you change the direction of it? So let's see how to do that. Now in the while loop, we are trying to detect the collision with the wall. How are you going to detect the collision with the wall? Just like in the snake game, we can do the same thing. Okay. If the ball dot y coordinate, if the y coordinate is about 300 or less than 300 minus 300, then it is a collision. If the y coordinate is above 300 or if the y coordinate of the ball. So y-core is a method which is available in the turtle module. So on the turtle class, since ball is a turtle class because it has inherited, we are directly calling on y. Its y coordinate. Now there we need to bounce. Whenever it is 300 or minus 300, we need to bounce. So let's write the logic for it. Let's write a method. So here what we have done is we have hard coded the x coordinates and y coordinates. We can actually remove them and write as so hold on. Let's write bounce first. So whenever bounce happens, we are going to add two variables here. So instead of these two 10 and 10 hard coded, this 10 and 10. So this 10 and 10 instead of having them, we are going to have x move and y move so that we can reverse them. 10 to minus 10, minus 10 to 10, we can reverse them. So these two variables, we are going to have them here. So we have not done anything so far. We have only taken these two 10 and 10 values and we have placed them here. Earlier 10 and 10 were there. They were replaced with x move and y move. Now what we are trying to do is whenever there is a collision, we are trying to change the direction of y. We are multiplying with minus 1. If it is 10, now it will become minus 10. So which means if the ball is going up, it will come down by minus 10 like that. So whenever there is a collision, we are calling bounce. Let's try to see that. Now there is a collision with the ball. The ball is coming up, coming down. But there is a small problem. Again, run it. The ball is going out of the screen. If you observe it, the ball is going out of the screen and again coming back. We don't want that to happen. So for that reason, instead of having 300 and minus 300, we have to experiment with these numbers. Let's have 280 and 280. You have to experiment with these numbers. Now, it has touched the wall and it has come back and it is clear now. Okay. You can see that it has touched the ball and it has come back. Okay. Okay. Now let's try to see the collision with the paddle. Okay. Now how do you detect the collision between the ball and the paddle? So that is somewhat tricky part here because in the earlier game, if when you have seen the snake game, the head of the snake and the actual food, they were you can measure the distance between them because they were 20 by 20 size. But here the paddle is of different size, which is a turtle, and again ball is of different size, which is a turtle. So what I mean to say is the center of the paddle will be somewhere here, and when you measure the distance will also always be measured from the center. So when the ball collides with the center of the paddle, it is very easy to see that the distance is very, I mean, you can measure the distance and accordingly you can say there is a collision. But then go to the next diagram. If the ball collides here, then our number will fail because the center of the paddle is here and the ball is here and the distance has increased. So how can I put that distance? If I put that total distance as 50, then as the ball approaches the pedal without touching the pedal, it will reverse the direction. So what I mean to say is, go back to the previous diagram. If the ball collides with the center, there will be no problem. We can use some distance and say that there is a collision. Next slide. But if the ball is actually colliding here, then the distance is more. Now, if I try to use this distance as the colliding distance, then the problem will be even without approaching the paddle, our ball will be detected as it is a collision. So, in order to fix it, we are going to use a different logic. Go to the next slide. Now, upon crossing some limit on the x-axis and upon having some distance with the paddle, we are going to use both the parameters. One is the crossing the x-axis, crossing the x value to some value, and then having a some distance with the ball. We can handle all the cases, right? So let's see the program. I'll show you the program, it will be clear. Now let's try to detect the collision with the right paddle. Okay. We will do the same with left paddle also, but for now let's try to see the distance with the right paddle. Now we have to check the x coordinate of the ball and also the distance of the ball from the paddle. Okay. If the distance of the ball from the paddle, which is right paddle in this case, if that is less than, let us say 50, some random number, which is close to that, and ball's x coordinate is, let us say, greater than 340. These two numbers you have to experiment and you have to learn about them. If this is the case, which means the ball is crossing some x coordinate and also the ball is of some distance from the paddle. If these two conditions happen, then there is collision. Let's try to print collision. And now let's see this. Now, when the ball has collided, collision has been printed. So, since it is a while loop, it is going to happen more than one time. But anyway, collision has been detected. Now, what should we do if we get a collision? See, when there is a collision with the paddle, its x direction has to be changed. Earlier with the ball, its y direction has been changed. Now, if it is with the paddles, its x direction has to change. It has to go in the opposite direction with the x coordinate. So we are going to use a new method called bounce. So here we are going to use, earlier we have changed the direction in the y-axis. That is why let's call it as bounce y. Let's refactor it. To be sure, just check if the name has changed here. When you refactor and rename, it is going to change here also. So bounce y, which means if it is with the walls, y direction has to be changed. If it is with the paddles, x direction has to be changed. Simple logic. So now let's try to do one more method called bounce x, which will change the x direction. Now let's try to put the bounce there instead of print collision. Now whenever there is a collision with the right paddle, now the ball is going to change the direction in the x direction. Okay, now let's try to run it and see. Now the ball is going to have a collision and it has changed the direction. You have seen that. Now we can do the same for the left one also. Left paddle. We have seen only for right paddle. Let's try to do the same for left paddle also. So we are going to check the collision with the right paddle as well as left paddle. Whenever the collision happens, we are going to change the x direction by doing x equal to -1. Not -50, have 50. Now let's see both the directions, both the paddles. I don't know if he's able to catch the ball. Yeah, he's able to catch the ball. So now if you observe it, there is one, let's run it. If you observe it, there is one problem. The ball seems to be going inside the paddle, right? If you see that the ball is going inside the paddle, and now we have to adjust the numbers. That's it. Okay. So instead of having 340, let's try to have 320 and see. Now the ball doesn't go inside the paddle. So these numbers you have to play with them. How did I come up with these numbers? I played with them. So I experimented and I found out. Okay. Fine. Thank you. Now let's see what if the paddle misses the ball. So if the paddle doesn't catch the ball, then it is going to hit the wall on the right and left. So we have to detect that it has happened, and whenever a player misses it, then the ball has to come to the center, and again the game has to continue, and the points have to be distributed accordingly. Okay, so let's see that. First, let's try to see how to detect whether the ball has missed the ball or missed the paddle. Let's try to do it with the right paddle first, and then we will see the left paddle. If ball dot x coordinate, so we know that it is 400 minus 400 to 400. So if it reaches anywhere beyond 380, we can say that the ball has missed. So if the ball's x coordinate happens to be greater than 380, it means that the ball has missed the paddle. Then we can perform the actual actions here. So in this video, we are not going to set these scores. In the next video, we will see the scores part. But for now, what we want is, again, we have to come back to the reset to the 0-0 position. Ball has to come to 0-0, and again it has to start playing. Now, let's write the reset position. We have to go to 0-0 position and we have to start playing. Go to 0-0 and it will start playing. Now you can see that now the ball misses the paddle and again it has come to 0 position, but there is a small problem here. Now when the ball misses the paddle on the right side, now the ball is again coming to the right side, but I want the chance to be given to the left side, which means if the right side misses, the ball should go to the left side, And if the left side misses, ball should come to the right side. This functionality I want. Okay. So again we can do the same. We have to change the x direction. We are changing the x direction. So whenever the ball misses, we are changing the x direction. It will go to the opposite direction. So it will keep on going to the opposite direction. Okay. So now it has gone to the opposite direction. If he misses, then this guy is going to get the chance now. But anyway, we didn't add the functionality for the left paddle. We will add it. So if you observe it, for the right paddle we have written this line, and for the left paddle we are writing again one more line. Actually, both of them can be combined into a single condition, but there will be a problem there. If you try to write both of them in a single condition, then keeping track of the scores will be a problem later. So now, if I write it separately, then I know who has got the point, who got the point. That thing that I will know if I write them separately. If the ball is going off in the right side, then the left one should get the point. If the ball is going off in the left side, right one should get the point. We will see that points later. Okay. Now let's try to run it. Looks like there is some problem here. The ball is not moving. Go to the ball class and see if there is any line missing there. So reset position has been done, and then bounce has been added. Go up. I think in the while loop, move is not being called. Just check the while loop. In the while loop, ball.move is being called. Well, the problem in the code was there was a typing mistake. So here it is greater than 380 is minus 380 is given. It has to be less than 380 minus 380. But x score is less than minus 380. Then again we are going to call it. Now it will work. Now you can say that it has missed, and the other side is getting the ball, and the other side has missed, and this side is getting the ball. Okay. So now let's try to add the scoreboard to the program so that we can keep track of whose score is what. So I forgot to tell you this is a two-player game. So left one, someone is playing left side, someone is playing right side, and now it is a two-player game. Now in the two-player game, we are supposed to maintain the scores also. We will see that in the next one. Okay. Now let's create the scoreboard class, which will inherit the turtle class. So let's create one more file. Let's name it as scoreboard.py. And now in the scoreboard.py, we are creating a new class. Let's import turtle first. And now let's create the scoreboard class. You have to write the init and super init of the super class. You have to call the super init of the super class always. Whenever you do inheritance, you have to call the super class as in init method. And then color to white. The score has to appear in white, otherwise the default color is black. And we don't want anything to be written onto the screen. No lines have to be drawn. That is why penna. And then we are going to say hide turtle. We don't want the turtle symbol here. We just want the score. And let us say we are declaring two variables, one for what is the left side score and one for what is the right side score, left player and right player. So left player score is L score and right player score is R score. Initially let them be 0 0 when I start the game, and then let's try to display the score onto the board using right. There has to be a go to statement. Now, where do you want to display this score? If I don't write anything, it will go to the origin. So I want it to be at the top and at the left side, the left score, and the right score has to be at the top and the right side. Not completely right, a bit right. Therefore, left score is going to minus 100 comma 200. You play with these values. Okay, it is very difficult to get it right away. You play with the values, you'll understand it. So minus 100 and 200. There I want to write the left score. I want to align it to the center. And font is Courier font. You can experiment with the font and size and everything. Position. This is not actually any science. You have to experiment and you have to know them. Let's try to print it first. Let's import it in the main.py scoreboard. And let's create an object of it. Capital S. Now you can see that score of 0 is being printed there. Now let's try to print the right one score also. Left score you have seen. The same way you can print the left score, right score also. But the right, let's put it at 100, 100 and 200. And the right score is now printed. Now you can see that left score is there and right score is there. If you feel that these numbers are too big, you can change the size. You can increase the font size and decrease the font size, and you can see what actually fits you. Okay. Now we have to update the score. For that you have to know who has missed the paddle. Now here we know that if this condition happens, then right one has missed the paddle, then the left score has to be increased by 1. Scoreboard.l score. We are calling a new method L point, which will increase the score. Otherwise, you can directly using the object, you can also access the L score directly and increase it, but it is better if you write like this. Now instead of writing all these lines again and again in order to update the score, let's try to write a method called update score and put all these lines there, displaying left score and right score. We want to do it again and again whenever there is some point, right? So instead of putting it separately, instead of putting it here, I am separately writing it in a different function. And now I will call that method there. Now you can increase the point L score plus equal to 1, and after that you can call the update scoreboard method. and you can do the same thing. So let's see. Now left one has got 1. So there is a small problem here. It is overwriting. So one more time. Now you can see that it is continuously overwriting. So we have to clear the scoreboard before you again write it. Okay, so let's clear it. Now whenever the update is happening, let's clear it and then update it. Now left one is going to get the point. Now you can see that again left one has got the point. Okay, so you can do the same for right one also. Now whenever the left one misses, you can increase the right point. Write a method for that. Write a method for right point. It is doing the same thing. It is incrementing the right score and then updating the scoreboard. Now you can see that both sides the points are updated. Let's now see how to increase the speed of the ball. Okay. Now let's try to increase the speed of the ball. So on where do you want to increase the speed of the ball is whenever the ball touches the paddle, I want to increase the speed of the ball a little bit every time. Every time it touches either left paddle or right paddle. And again when the game begins again, when the ball comes to the center and again the next game begins, I want it to be again normal speed, and every time it has to go from normal speed to increase. Where do you see the speed here? The speed is set because of this line time dot sleep equal to 0.1, which means it is refreshing every 0.1 seconds. Now if you decrease this number, the speed will increase. Okay, how can I decrease this number? You can subtract something from it, but if I keep doing it, it will go to negative side. Instead of that, let us multiply it with 0.9. Then every time it will decrease by 10%, 10%, 10%. If I keep on multiplying by 0.9, every time it is decreased by 10% this number, and therefore the speed will increase by 10%. Even though this number is decreasing, speed will increase. Okay. Now instead of having that number hard coded, let's try to change it. In the ball class, let's have one more variable called move speed, and initially let us say its value is 0.1 only, and now in the main class check the speed to move speed. Here whatever the sleep time is, set it to 0.1, which is move speed. Now whenever there is a touch with the paddle, I want to increase the speed, which means I want to decrease the timer. So that you can see it in bounce X. You know that bounce X will happen whenever we touch the screen, bounce X will be called. Therefore in bounce X method itself, we are going to change the speed, self.move speed, multiply it with 0.9, whatever the existing value is, multiply with 0.9, and whenever the game is over, one game is over, and again when you are coming to the beginning of the next game, then we want the speed to be again 0.1. So that is why in the reset position, we are again giving the move speed to 0.1. Now let's see that the speed will increase a bit. You might have noticed the speed has increased, and again when it touches this, the speed will increase a bit. You can see that the speed is becoming more and more. Right? So like this the game will happen. So this is how you design the Pong game. Now you can experiment and design the game on your own. You need not follow the method that I have used. You can follow any method, and also you can change the appearance of the game if you want. You can put paddles to be of different color, ball to be of different color, and scoreboard to be of different color. You can experiment and find, just see which one suits you. Okay, thank you.